Everyone, I welcome you all to this class. This is mathematics class, and today we will be looking at the topic argument of a complex number. We said that for us to understand this concept, let's see what we have written down here. Any one of the polar angles of a complex number z, denoted by arc z, is called the argument of z. So the argument of z is any one of the polar angles of z. It means that you can get as many as such angles, but any one of the polar angles of z is called the argument of z. How do we get the polar angles of z? Look at this diagram here. Let's say that I have a complex number located here, and this line is the length of the complex number, which we call the modulus of z. Sometimes we use r to stand for it. So, which is the length of the complex number. And let's say that this complex number make an angle what? Theta, with the positive x-axis. Now, if this complex number make an angle theta with the positive x-axis, it can make an angle theta plus 2 pi k, where k is equal to plus or minus 1, plus or minus 2. That is, k is an integer, any integer at all. Now, from this diagram, if I draw a line like this, if I go like this, if I complete the circle, I've gone 2 pi. For instance, if k is 1, I've gone 2 pi. You go again. So I've gone, if k is 1, I've gone 2 pi plus theta. So it means that there are many such angles. If I rotate again, I'll go again another pi again. That is, k will be 2. I'll have 4 pi. Then I'll rotate again, reach here. I'll have theta plus 4 pi. So this you can, from this diagram, it means that there are many such angles you can get. So that is the understanding of what we mean by this argument of a complex number. The argument of z that satisfies this inequality, let's call it theta sub p. The argument of z that satisfies this inequality, minus pi strictly less than theta sub p less than or equal to pi, is called the principal argument of z. So the principal argument of z is the argument of z that satisfies this inequality, and that every complex number has what? One and only one principal argument. That principal argument is denoted by arc z. In this one, if you want to spell it, it's not like the first one with the first arc z. The first arc z started with small letter a. Then this, for principal argument, you start with capital letter A. Now, the note we are writing here is that I say note arg of z, that is the one that begins with small letter, that is the argument of z. When we use the one of small letter, we are talking about all such possible angles that z could make. If I use capital letter, I'm talking about that angle, that angle that z made that satisfies this inequality. So the set arc z is given by arc z is equal to set of all principal arguments of z plus 2k pi, where k is any integer. So to get the set of all such possible angles, we first of all get what? The principal argument. When you get the principal argument, the small argument, that is the set of all such possible angles, will be principal argument plus 2k pi. That will give you the set of all such possible angles, where k is any integer. So k is 0 plus or minus 1 plus or minus 2 and so on. So if we want to get the principal argument, we have a formula we can use to get it. I want to get the principal argument. What is the formula that I'm supposed to use? Now, if the complex number lies in the first quadrant or the fourth quadrant, you know, at the first quadrant and fourth quadrant, your x will be what? The real part will be what? Positive. This is the positive part of x. Then at that point, the formula you're going to use is simply tan inverse of y over x. Y is the imaginary part of the complex number divided by x is what? The real part. Now, if the complex number lies at the second quadrant, and second quadrant, x is what? You have the negative part of x, that's the negative x, as x2 is negative, that's the real part is negative. While the imaginary part is that's the imaginary part is either 0 or greater than 0. Then the formula you are going to use is tan inverse of y over x plus pi. That's what you are going to use. Now, if the complex number is lying at the third quadrant, the formula you are going to use is tan inverse of y over x minus pi. And in this happens when x is negative, because at third quadrant x is negative. Then y2, this is negative y as is. Y2 will be what? Negative at the third quadrant. So this is the formula you are going to use to calculate it. Then what if x is let me say x is 0. So if x is 0, you are going to get pi. You have pi over 2 if x equals 0 and y is greater than 0. If x is 0 and y is greater than 0, that's the real part is 0 and the imaginary part is greater than 0, you are going to get pi over 2. If you get negative pi over 2 if x is 0 and y is negative. If x is 0 and the imaginary part is negative, less than 0, you are going to get what? Pi, negative pi over 2. So these are the formulas we are going to use for any calculation we are going to make here to get the principal argument. Let's find the principal argument of this complex number. Solution. So this complex number, the real part, I told you that real part in our previous video, I told you that real part is that part that does not go with I. So 3 is the real part, while the imaginary part is the coefficient of I. That's 3 square root of 3 is the imaginary part. Both the real part and the imaginary part are what? Positive. So if they are positive, the major thing is to note here is that what? The real part is what? Positive. From this formula, if x is positive, if the real part is positive, use the formula. The imaginary part can be any real number, but the major thing is that if the real part is positive, then your principal argument, arg of z, will be equal to what? Tan inverse of y over x. Tan inverse is the same as arctan. So the y is the imaginary part, that's coefficients of I. We are going to have tan inverse of 3 root 3 divided by x is the real part, that's 3. This will be tan inverse of 3 divided 3, you are going to get 1 times root 3. So you have tan inverse of root 3. Tan inverse of root 3 is 60 degrees. But if you are solving anything on this principal argument and argument, the angle you are going to get, you must convert it to what? Radian. You must convert it to radian. So to convert 60 degrees to radian, simply do 60 degrees times pi over 180 degrees. So 0 cancel 0. 6 divide 6 1. 6 divide 18 3. So you get pi. So this will be pi over 3. So this is the principal argument of this very complex number. So see you in the next video. In the next video, we are going to solve more questions and know how we can get principal argument of other complex numbers we are going to write. Thank you so much.